Hi, this is Professor Fernandez, and we're talking about video 3 in lesson 10 here. The topic is the product rule, and I'm going to go through a couple of examples from Calculus Simplified to help you get used to get comfortable with the product rule. First thing I'll say is that, at this point in the course, we're studying derivative rules, and these derivative rules are generally named for the type of function or function upper family that you are looking to differentiate. So in video 10.2, for example, we talked about the power rule, and that was the rule for differentiating power functions, functions of the form x to the n. There's a nested property to these rules, by which I mean we're going to be using that power rule in this video. We're also going to be using the results of video 10.1, which talked about the constant multiple, the sum, difference, and constant multiple rules. So we're going to be using that in this video as well. So the point in pointing all that out is to encourage you to check out those two videos if you want more information about those topics. So let's talk about the product rule in this video. So I've put the product rule theorem down here. So I'm going to zoom in here and then review this for you. Suppose f and g are both differentiable. Once again, we're assuming we're working with differentiable functions. We've talked before in the video series about what that means. Encourage you to review that. Well, here it is. The derivative of the product rule of two functions f and g is, and this is where there are various ways to try to remember this, but long story short, it's the derivative of the first meaning the first in the product, times the second, plus the first times the derivative of the second. So that's how I remember it. I think that's how most people remember it. There are various other techniques you could use to try to remember the product rule, but I'm just going to stick with that one for purposes of shortening the length of the video. So let's go ahead and apply it here in these two examples. So here's example 3.24. Differentiate h of x equals this. As with the power rule, the first thing to do when you are going to apply the product rule is making sure that you can see the product, right? So is the function already expressed as a product? I put down this example, down here to discuss specifically that point. For this example, it already is given to us in product form. This is our f of x, and this is our g of x. Put them in different colors. This is our g of x. So we could just, do a by-the-book application of the product rule. What do I mean by that? We could write down the product rule, derivative of the first times the second, keep my colors consistent, plus the first times the derivative of the second. There we go. So like all the other derivative rules we've been studying, the sum, difference, constant multiple, derivative rules allow us to take a function that is often a combination of other functions and then break down its derivative into the derivatives of those other functions. Same deal is happening here. This is a product of two functions, f and g, as we've seen here, and its derivative, if I know the derivative of f and the derivative of g, and I assemble it in this fashion, then that gives me the derivative of h. So that's what I'm going to do. So depending on your level of comfort, this may be the first time you're doing the product rule. So on the side here, it might pay to just go a little slow. We want the derivative of f, so let's go off and calculate that. F of x is 2x minus 3, 2x minus 3, and we'll differentiate that. Zoom in a bit here. This is a linear function. We know its derivative is the same as the slope of this line, which is 2. So we could just say equals 2, call it a day, or we could run through some of the steps. It is a difference of the functions 2x and 3. 2x is a multiple of the function x, okay? And then we go back to some of the either properties we already talked about, results I should say, or back to the linear function thing. The derivative of x is 1. Could also use the power rule there. The derivative of 3, constant function, is 0. So here's the two that we talked about before. Okay, and we also need the derivative of g, so g prime of x. Well, g of x up here is 4x cubed minus 1 derivative. So here again, we use the difference rule. So this is going to be the difference of the derivatives 4x cubed and 1. Use the constant multiple rule. There we go. And then use the power rule that was in the previous video. So I'm just going to zoom out here. Video 10.2. So check that one out for a review. X cubed, the derivative there, bring down the 3. X, subtract 1. And then minus the derivative of 1, constant function, is 0. So 4 times 3x, 3 minus 1, 2. That's 12x squared. Great. So that is my g prime. This is my f prime. And now I'm just going to plop them in where they go. F prime goes there. So 2. G prime goes there. So 12x squared. And then now I just put in my f and g from the original function. So f of x, 2x minus 3, that goes over here, 2x minus 3. And then g of x, 4x cubed minus 1, that goes over here, 4x cubed minus 1. Okay, plus. All right, so I've chosen to present this power rule, product rule calculation in a very kind of methodical and slow and detailed way. This is not typically how I, for example, would calculate the product rule for this function. But again, I'm doing this assuming that you may be coming to this new. And so I'm giving you a systematic way to just, off to the side, find the derivative of f, find the derivative of g, write down the product rule, and then just put things where they go and simplify. And that minimizes the chances that, you'll make a mistake somewhere. Those mistakes will propagate throughout to the final problem. Okay, so just simplification here, multiplying out the 2 here, 8x cubed minus 2, plus multiplying the 12x squared to the 2 is 24x cubed, multiplying it to the 3 is 36x squared. And then I'm just going to simplify and collect like terms here. 24 plus 8, that's 32x cubed. Next one up is minus 36x squared, and then the last one, minus 2. So that is my derivative of h. Great. Okay, for this second example, I'm going to speed things up a little bit. In other words, I'm not going to do this to show you how you could probably differentiate using the product rule faster. And then this is also the example where I mentioned earlier that a lot of this is in the presentation of the function. When do you use the product rule? Well, you have to view the function as a product to begin with. Let's take a look at this function. Some of you out there who know some calculus might look at this function and you might say, oh, I need to use the chain rule. And the answer is not necessarily, right? If you don't know what the chain rule is, that's okay. Stay tuned. That's coming up in the next video. But we're going to use the product rule. To do that, I have to express this function as a product. How do I do that? The clue here is in the exponent. So something squared is something times that same something. Aha! So we have now expressed h of x as a product, and we can therefore use the product rule. So I'm going to simplify things, speed things up here. To use the product rule, it's the derivative of the first times the second, which happens to be the same function. That's okay. Plus the first times the derivative of the second. Okay. So again, these f and g are the same function here. It's a very special case, but it's okay. The product rule still applies. And now I calculate each one of these derivatives. So before doing that, I'm just going to zoom out here to compare things. Again, the first example, I did the way I did to kind of give you a systematic procedure. And I calculated the derivatives on the side and then plopped them in, assembled things. Here, you can see the difference. I'm calculating those derivatives embedded into the final answer. So I'm skipping all this stuff over here. That's good potentially or bad potentially, depending on whether you're prone to make small mistakes. So I encourage you to use whichever one of these makes most sense for you, and might want to just experiment to see which one's more comfortable. So 3x minus 1 derivative, we could go through all the usual stuff, difference of 3x derivative and 1 derivative and do all that. Or we could just say, hey, linear function, derivative is the slope 3. So I'm just going to do that for speed purposes. And then over here, same deal. It's the same function. So 3x minus 1 derivative, linear function, derivative is the slope, so 3. Great. And notice that I just have 2 of the same things being added. So I just double it. 3 plus 3, 6. 3x minus 1. And that is my derivative for h. Again, for those of you that can see the chain rule happening here, you might recognize this as 2 times 3x minus 1 to the first times 3, right? Derivative of the outside times the derivative of the inside, and 3 times 2 gives you 6. Everyone else watching who has never heard of the chain rule, just ignore everything I just said and watch the next video in this series where we talk about the chain rule. Okay, so that is the video. One last thing I want to mention with the product rule. Again, f and g have to be differentiable. This is a theorem, so I want to make sure at some point, unless the question asks specifically or explicitly, you might just want to think about it, convince yourself the functions you're working with are differentiable before you go off and calculate the derivatives. I didn't do that here because I wanted to illustrate the product rule itself and the mechanics of it. But just as a quick check, this is a linear function, this is a cubic function, this is a linear function that's squared to a quadratic. So these are basically x to the fourth-ish, and this is x squared-ish. These are polynomials, they're differentiable everywhere, so product rule applies. Thanks for watching.